Absolute value, solving an equation part 2. Supposedly we have an equation to solve. Absolute value of x is equal to 3. So you're asking yourself a question, what x should be equal to in order to balance this statement? So by inspection, by try and error, you can say, okay, 1, absolute value 1, not equal to 3, and so on. And quite fast you will conclude that absolute value of x is equal to 3 when x is equal to 3. That's fine. But you have to be aware that a linear equation involving absolute value most likely will have two solutions. So where's the other value of x? So you can recall definition of absolute value and then quickly observe that absolute value of negative 3 will also give you 3. So x is equal to negative 3. And that will be it. So that will be this and that. Excellent. So now, visual representation. So this is the graph that represents an absolute value of x function, and y is equal to 3 represents a horizontal line. So these two graphs would intersect at 2 points marked in blue. So the first one here on the left, when x is equal to negative 3, the one on the right, x is equal to positive 3. So you see graphical solution with two answers, and this is a very simplistic algebraic solution with two answers as well. Now, what would happen if absolute value of x was equal to negative 3? Is this ever possible? If you recall absolute value definition, you would say no. Because remember, you either positive or 0. You cannot have absolute value of any value equal to negative number. So you would conclude no solutions here. Excellent. Now, we can modify this equation and create as complex as we can think of, but still in the context of linear equation for now. Say absolute value of x minus 3 is equal to 4. So you either positive or 0. Okay, so this statement makes sense because absolute value of something is equal to 4. So that is an example that you anticipate will have a solution. So by the definition, x minus 3 is equal to 4 when x minus 3 is greater than 0, or remember from the definition, negative x minus 3 is equal to 4. Just recall the definition of absolute value. When the expression inside is positive, so that is equal to a. When the expression inside is negative, so then the absolute value of a will be equal to negative a. So this is why you have this or that. And of course, the third case, 0, when a is equal to 0. So the first case, x is equal to 7. And the one here, you have to distribute negative x plus 3 is equal to 4. So negative x is equal to 1, and x is equal to negative 1. Excellent. So in order for this to be shown graphically, two things that you need to remember. Absolute value of x minus 3 graph. So this is a horizontal shift 3 units to the right. So that will be a V shape So this must be 0.3. Okay, and there is a horizontal line. Y is equal to 4. So how do I know where this horizontal line goes with relation to this left branch? So the y-intercept is at 3. So when x is equal to 0, so absolute value of 3, negative 3 is 3. So this point is 3. So you have to be above because you are 4. So one solution will be negative and the other will be positive. So this is the negative root and this is the positive root. If the sketch was done to scale with proper unit, you will see that this is negative 1 and this is 7. So the roots are negative 1 and 7. Now, solving inequalities involving absolute value. So let's say absolute value of x is less than 3 this time. So you're looking for all values of x that will be less than 3. So this time, instead of having a definite number or two numbers, the solution will be expressed in terms of an interval or section of a number line. So by inspection, recall a number line x. So the distance from 0, 3 units to the right, say 3 units to the left, and you have to be less than the distance from 0 to 3. So that portion from 0 to the right, or this distance from 0 to negative 3, not including negative 3, not including positive 3. So you anticipate that the final statement should contain all real numbers between negative 3 and positive 3. So we can write this using double inequality symbol. So negative 3 in between x, positive 3. So you read x is greater than negative 3 and x is less than positive 3. You can also use the interval notation. X is element negative 3, comma 3. So x belongs to that interval. So when solving inequalities involving absolute values, when absolute values is less than a number, you can generalize that statement and say that when absolute value of x is less than a, so this is equivalent to the following statement that x is contained between negative a and positive a. So this is worth remembering. In the next video, we'll do the opposite inequality, where the solution is quite different than this one here. And when working with more complex equations, you will still be using the same fundamental. So remember, absolute value of x is less than a. This translates into interval between negative a and positive a, regardless what goes inside of absolute value. Thank you for watching this video, and I'm inviting you to come back and watch part 3. Bye for now.